Example 4. Find the sum of the series, the sum from n equals 0 to infinity of open negative 1 closed to the power n over n factorial, correct to 3 decimal places. By definition, this is a sidebar. By definition, 0 factorial equals 1. Solution. We first observe that the series is convergent by the alternating series test because, number one, 1 over open n plus 1 closed factorial equals 1 over n factorial open n plus 1 closed is less than 1 over n factorial. And number 2, 0 is less than 1 over n factorial, which means that 1 over n factorial is greater than 0, but it's less than 1 over n. Approaching 0, so 1 over n factorial approaches 0 as n approaches infinity. To get a feel for how many terms we need to use in our approximation, let's write out the first few terms of the series. S equals 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial minus 1 over 7 factorial, and ellipsis equals equals 1 minus 1 plus 1 half minus 1/6 plus 1/24 minus 1 over 120 plus 1 over 720 minus 1 over 5040 plus and so forth. Notice that b sub 7 equals 1 over 5040, which is less than 1 over 5000, equals 0.0002, and s sub 6 equals 1 minus 1 plus 1 half minus 1/6 plus 1/24 minus 1/120th plus 1 over 720 is approximately equal to 0.368056. By the alternating series estimation theorem, we know that S minus S sub 6 by the alternating series estimation theorem, we know that the absolute value of S minus S sub 6 is less than or equal to b sub 7, which is less than or equal to 0.0002. This error of less than 0.002 does not affect the third decimal place. So we have S is approximately equal to 0.368, correct to 3 decimal places. Sidebar. In section 11.10, we will prove that e to the power x equals the absolute value of, e to the x, restarting the sidebar. In section 11.10, we will prove that e to the power x equals the sum from n equals 0 to infinity of x to the power n over n factorial for all x. So what we have obtained in example 4 is actually an approximation to the number e to the power -1. Note the rule that the error in using s sub n to approximate s is smaller than the first neglected term is in general valid only for alternating series that satisfy the conditions of the alternating series estimation theorem. The rule does not apply to other types of series.